Hello everyone, welcome back. So in this session we will talk about what are the different types of packages in Python. Okay, so before starting that, first of all let's understand what is a package. Package is nothing but a way of organizing directory, subdirectory, and file. Okay, so package is just a way of organizing the directory, subdirectory and files of your project. Okay, now let's see what are the different types of packaging system allowed in the Python. So there are two types of packages in Python. Two types of packages in Python. First one is the regular package. First one is the regular package and second one is the namespace package. Namespace package. So two types of packages are allowed in Python. First one is regular package and second one is the namespace package. Now let's see each one of these in detail. So first one is the regular package. Okay. So this type of package existed in Python version 3.2 and earlier. Okay, so this type of packaging system was existed in Python version 3.2 and earlier. So when we were creating subdirectories, so if I go here in my PyCharm, so when we were creating subdirectories and inside subdirectories we were creating our module file. So at that time what was happening, by default we had to explicitly create another file called _init _py file, because of this file Python treats all the directories, subdirectories and the module file as a package. Okay, so currently I am using Python version 3.12. so what happened, I can create this packaging system and show you how the regular packaging were used earlier. Okay, so we can write here that in regular package is implemented as a directory and all its subdirectories containing _init _dot py file. Okay, so this double underscore init py file is imported implicitly whenever regular package is implemented. Okay, is implemented. So earlier when we were creating subdirectories and defining the modules inside it, so in some of the IDs double underscore init double underscore dot py file were automatically created, and in some IDs we have to explicitly create it. Okay, now we can treat double underscore init double underscore dot py file as any other file in Python. Okay, now let's say, if we remember our previous session, we wrote our logic or we created our functions in maths.py file. So what happens if I place all those code inside the double underscore init double underscore dot py file? Okay, now let's see here. So let's say I have placed, first of all, let's create this double underscore init double underscore dot py file inside each directory and subdirectory. Okay, so you need to remember that if you are using Python version above 3.2, then if you want to implement regular package in your Python, you have to create this double underscore init double underscore dot py file in all the directories and the subdirectory. Okay, so first of all, let's create this double underscore init double underscore dot py file in directory and subdirectory. So we will start with directory. So here I can write double underscore init double underscore dot py. So this file is created. Now let's create the same file in our subdirectory, that is mathematics. Double underscore init double underscore dot py. Now, as I said, that whatever the function that I had declared here, instead of it, if I remove all the function from here and place it inside the double underscore init double underscore dot py file, which is again inside the mathematics subdirectory. So I have written all the logic inside in the double underscore init double underscore dot py file, which is inside the mathematics subdirectory. Now in that case, if I need to call these two functions, so how I can call it? So the methods of importing this module will become something like this. Import, the first method is import, and then the name of the directory, subdirectory is sufficient. You don't need to specify this dot and then double underscore init double underscore dot py file. So you don't need to specify something like this. You don't need to specify it. Why? Because as I said that this file will be implicitly called. So in order to call the function, we can just specify mathematics dot add, and inside add we can just pass the value. Okay, so this is the first way. Now the second way is we can create an alias also. So we can write something like this: import mathematics as m, and then at the time of calling the function we can write m dot add function 5, 4. Now let's see these two methods first in PyCharm. So I'll say import mathematics, and now using this subdirectory name, this mathematics is what? It is a subdirectory. It is our subdirectory. If you look at this directory structure on the left side, it is a subdirectory, and inside this subdirectory there is _init_double_dot.py file which contains the functions. Okay, and I need to call this function inside my main file, which is learningpython.py. Okay, so I can write add, and then I can say pass two values 5, 4. Now let's run this. So you can see here it is giving us correct result. Now similarly, if I want to declare one alias here, so instead of this I can write alias. Again it is giving us correct result. Okay, now the third method is from, then I'll just have to specify subdirectory mathematics, and then import, and then the name of the function is sufficient. Okay, so let's call this function like this: from mathematics import add, and then I don't need to specify alias name or the module name in prefix. So now when I run it, you can see here we are again getting correct result. And the fourth method is from mathematics import asterisk. Okay, and then if I have to call the add function, I can just use the name of the function. I don't need to specify alias name or the module name in prefix. So instead of this add, I make it asterisk. Now when I run it, you can see here it is again giving us the same result. Now as we know that this asterisk enables us to call all the functions of this module, of the init module. Okay, but I want to put a restriction. I want to put a restriction like this, that even though if the developer specifies asterisk, then also the developer should be able to call only add function, not the subtract function mentioned here. I want only the add function of my module should be called, not the subtract. So how I can do that? So first of all, I'll move this code back here in maths.py. Okay, and then inside this subdirectory mathematics _init_dot.py, in this file what I'll do, I'll import this mathematics, this maths module. Okay, so I'll say from mathematics.maths import asterisk, and then here what I'll do, I'll specify one global variable called all, all equals to all equals to, inside it I'll specify the name of the function. Now let's go back and run this code. So you can see here it is working correctly. But what about the subtract function? Now let's try to run this again. So you can see here add function executed successfully, but subtract is not. Why? Because in the init.py file, _init_.py file, I have put a restriction using this global variable double underscore all double underscore, that only add function will be allowed. So inside this global variable, inside this list, whatever the name I'll specify, whatever the function name I'll specify here, only that function can be called inside the main file or any other Python file. And that is why we are not able to call this function subtract here. Okay. So using this init double underscore init double underscore dot py file plays a very important role in our regular packaging system. Okay. So even though the user has used asterisk here, but then also he or she won't be able to call subtract function. Why? Because we haven't specified the function here. Only add function is allowed to be called. Okay. So this is the regular package concept in Python. Okay. Now let's move towards the second type of the package, which is called the namespace package. So this package system is used in the newer versions of the Python. Okay. So namespace package contains various portions, where each portion is a subdirectory to directory. Okay. So namespace package basically contains various portions where each portion is a subdirectory to a directory, and these subdirectories may reside at different locations and different format. So earlier in the regular package system, all the subdirectories were residing in the contiguous memory location, one after the another. But here in the namespace package, this package can have different portions, and each portion has a directory and subdirectory, but these subdirectories will not reside in a contiguous memory location. Okay. They might be scattered over different memory locations. Okay. Different format. Okay. Also, there is no double underscore init double underscore dot py file. That is why, since I am using the Python version 3.12, so when I was importing the module in our previous session, I was not using this double underscore init double underscore dot py file. Okay. Because in the current version, it is not really needed. Okay. Then the fourth thing is, it is possible that directory slash subdirectory 1, okay, 1 is not located next to directory slash subdirectory subdirectory 2, okay, on disk. Okay, so in this case Python will create a namespace package. Namespace package on the top of the directory. On the top of the directory whenever it or its subdirectories are imported. Okay, so in namespace packaging system, there is a possibility that our subdirectories are not located in the contiguous memory location. They might be scattered over different location. So what happens when we call any module? So a namespace is created on the top of the directory. Okay, just to keep track whether this subdirectory and the other subdirectory belongs to the same package. Okay, so in case if the path of directory changes the namespace package uses custom iterable type to perform a new search for the portions on next import. Okay, so what does it mean? So let's say we defined one directory structure, and later on the location of the directory was changed. Okay, and now if the directory location, or you can say subdirectory location, was changed, then in that case, when we try to import the module again, namespace package will use a custom iterable type to search the new path of its subdirectory. Okay, so there is a double underscore path attribute is there, which contains the list of the directories. Okay, so this particular attribute holds the list of all the directories and the subdirectory, and this resides in the sys module. Okay, this module, in this module, this particular attribute resides, and this holds all the directories of a package. Okay, so in this way the packaging system works in regular package system as well as in the namespace package system. That's all for this session. Thank you.